Microdosing, taking subperceptual doses of psychedelics like psilocybin, is having a moment. Depending on who you ask, it's either Silicon Valley's latest productivity hack, a subtle mood lifter for midlife crises, or a clever way to get more joy out of meetings without, you know, seeing colors talk. But beyond the headlines and the hipster hype, scientists are starting to ask a more grounded question. Could tiny doses of psychedelics deliver macroscale health benefits at the cellular level, especially in the context of aging? It might sound improbable that a barely there amount of psilocybin could do more than just take the edge off your emails, but early data suggests that microdosing may subtly influence systems well beyond the brain, including energy metabolism, oxidative stress, and even telomere integrity. That's right. The psychedelic breadcrumbs you sprinkle into your weekly routine could be whispering to your mitochondria and nudging your biological clock in a more youthful direction. Let's start with energy metabolism, the cellular equivalent of gas mileage. Aging cells are notorious for inefficient fuel use, thanks to declining mitochondrial performance. Psilocybin, even in low doses, seems to activate serotonin receptors that are closely linked to metabolic pathways and mitochondrial function. While full-dose studies have shown robust effects on brain energy utilization and synaptic activity, microdosing may deliver a consistent, lower-key enhancement of ADP production and mitochondrial resilience over time. It's not a jolt, it's more like a gentle cellular tune-up that keeps your energy systems from rusting out. Then there's oxidative stress, the grim reaper of aging cells. As mitochondria falter, they start leaking reactive oxygen species, ROS, which go on to damage DNA, proteins, and lipid membranes like tiny molecular vandals. Some rodent and cell culture studies hint that psilocybin and related tryptamines may possess antioxidant properties, not just by scavenging free radicals directly, but by modulating inflammatory and stress response genes. Microdosing could allow for these protective mechanisms to activate without the metabolic chaos of a full-blown trip, meaning your cells may quietly become more resistant to the wear and tear of time. But perhaps the most eyebrow-raising area of inquiry is telomere maintenance. Telomeres, the protective caps on the ends of chromosomes, shorten with age and stress, eventually triggering cellular senescence, a state of retirement for cells that often comes with inflammation and dysfunction. While no one's claiming that microdosing is the new telomerase enzyme, some early indicators suggest that psychedelics may influence telomere dynamics indirectly through stress reduction, epigenetic modulation, and improved systemic homeostasis. Chronic psychological stress is one of the most consistent predictors of accelerated telomere shortening. If microdosing improves emotional regulation, reduces cortisol levels, and promotes psychological resilience, it could, over time, help slow that fraying biological fuse. And it's not just the mind-body connection that's in play. Psychedelics appear to engage pathways involved in cellular plasticity. Think BDNF, brain-derived neurotrophic factor, which helps neurons grow and adapt, but also plays a role in metabolic regulation and inflammation outside the brain. Microdosing may gently upregulate these trophic factors, fostering not just mental flexibility, but system-wide adaptability. That's particularly relevant in aging, where rigidity, cognitive, emotional, and metabolic, is the enemy. Of course, we're still in early territory. Most of the data on microdosing comes from self-reported experiences, anecdotal logs, and small pilot studies. Large-scale clinical trials are rare, and almost none have focused on long-term biological aging markers like telomere length or NAD+ status. But the absence of data isn't the same as absence of effect. It just means we're waiting for science to catch up to curiosity. And given how deeply psychedelics interface with serotonin, inflammation, and stress, all aging accelerants, there's good reason to take the microdosing hypothesis seriously. So what we have is a tantalizing blend of neurobiology, bioenergetics, and a little mind-body mysticism. The idea that a dusting of psilocybin, too small to spark hallucinations, might instead spark subtle but meaningful enhancements in how our cells age, adapt, and perform. It's not about escaping reality. It's about gently reshaping the physiological terrain so that reality feels a bit easier to move through. In the future, microdosing could join the anti-aging toolbox alongside fasting mimetics, NAD+ precursors, senolytics, and adaptogens. It may not reverse gray hair or grant enlightenment on demand, but if it helps you think more clearly, stress less, move with purpose, and keep your cellular engines humming along into later decades, well, that's already a macro win.